Selection sort is a simple in place of comparison based sorting algorithm. It works by repeatedly finding the minimum or maximum element from the unsorted portion of the list and placing it at the beginning of sorted portion. Right. So here what happens is in this selection sort, we are going to, for ascending order, we are going to find out first in the selection sort, we are going to make two parts, left part, right part. Initially left container, it is empty. In the right container, whatever the input elements you have sent to the array, right, as an input, all elements will be in the right part. Left part is empty, right? So now what you do is by making the comparisons in the right part, that is in the inputted array element, you are going to find out smallest element. That smallest element, you have to place it in the first position of left part. That means one element is removed from the right part. After that, in the right part, whatever elements are present. So again, check which is the next smallest element in that, right? That is which is larger than this one. Then that element you place it beside this, and that means in the second position of the left part, right? One thing. Or in a simpler way, in the list, find out the smallest element and put it in the first place. By leaving the first place, from second place to last place, see which is the smallest element in that range, put it in the second place. From third to last place, again check out which is the smallest element, that you put it in the third place. Like this also, if you do, it will come. For ascending order, we do like this. So you can see here the list is conceptually divided into two parts, a sorted sublist and an unsorted sublist. So for each pass through the unsorted sublist, find the smallest element for ascending order. Largest element when you want to sort them in a descending order, right? Swap this found element with the first element of the unsorted sublist. This moves the smallest element to its correct position in the sorted sublist. In the bubble sort, we used to find out the largest element and we used to push it towards right so that it can sit in its right position, right? But this is what a reverse process, right? So here also n minus 1 comparison will be there. Time complexity, so means what, how much time it will take, that calculation will be there in this O notation. Selection sort has a time complexity of O n raised to 2 in all cases, best, average, and worst, where n is the number of elements. This makes it inefficient for larger data sets, right? So space complexity, it is an in-place algorithm, meaning it requires minimal additional memory, typically O of one auxiliary space. Stability, selection sort is a generally not stable, meaning the relative order of equal elements may not be resolved, right? So simplicity, it is known for its simplicity, ease of implementation, making it a common algorithm taught to beginners, right? So that's why usually selection sort, bubble sort are common techniques which will be taught to the beginners, right? Let us start our program. So here, so by taking the concept of that algorithm, whatever they have said, based on that, we'll write the program. Studio.h. Before that, shall we have some numbers first, right? So we'll have 9, 7, 5, to 8. Right, these are the numbers available, and here these are the indices available. So here remember, these are indices, and these are the elements of array. Right. So now here what you have to do, you have to find out the smallest element. So as usual, same comparison. One way is what? You have done a program to find the smallest element, right? You can use that technique. Or last time in the bubble sort, what we had used comparing maximum element like 9 greater than 7. You check 9 less than 7. Like that also you can get smallest element. So what I do, I'll take one variable min and I'll store a of 0 in it, right? First element is stored as a smallest element in the min. Compare this number with the next number, right? So min is less than a of 1, next element. A of 1 means what number it is? It is 9 less than 7, right? So it is false. So no swapping. And in the min, there is no change, right? So next, what do you do here? Again, next element. Min is less than a of 2. That is 9 is less than 5. Right, it is false. After that, min is less than a of 3. Min is 9. A of 3 is 2. Right? So here, one, okay. No, we have to do reverse comparison here, not with this. A of 1 is lesser than the min. Like this you have to go. Where A of 1 means 7. Less than min is how much? 9. 7 is less than 9. Right? So now we have to interchange. Right? So that means our new list will be 7, 9, 5, 2, 8. Right? So like this, see, okay. Now we'll go for, that means in the min now we have which variable? 1 second. You can do swapping of the element there itself, one technique. Or what you can do, in the min, you save 7. In the min, you save 7 because up to this much comparison, this is the smallest element. Next is a of 2 is less than the value present in the min. A of 2 is what? 5. 5 is less than 7. Yes, it is true. That means min is now we are having 5. Right. So similarly, a of 3 is less than min. So a of 3 means how much? 2 less than 5. It is true. So min is now 2. Right. So again a of 4 less than min. A of 4 means 8 less than 2. It is false. So minimum, we came to know that 2 is the smallest element. But what we want to do, we want to make this element to be shifted to the first place now. In the first round, in the second round, to the second place. So here what you have to do, along with storing, instead of storing the element into the min, you can have the position after completing the first round. After completing the first round, you have to swap the elements. You have to swap the element. The element has to be swapped with the first element. But we don't know where this number 2 is present in the array. We have copied only the value, but we haven't copied the position, right? So what we can do, along with saving this 7, we can also have one position variable, right? Position variable. In the position variable, 7 was present at index 1. Here in the position, 5 is present at second position. Position equal to, it is at 3. Yes. So that means what? Last element, the smallest element is present at index 3. Now you have to replace the first element with this one. That means 2 will come here. Then 2, 7, 5, 9, 8. Right. Now 2 is fixed now. Now you continue with 7 to 8. Right. So now here min will be considered as now 7. Position is considered as 1. Now you check A of 2 less than min. So A of 2 means how much? 5 less than 7. Condition is true. So in the min we are going to get 5. In the position we are going to get how much? 2. Now after that A of 3 less than min. So A of 3 is how much? 9 less than 5. So it is false. Min and position, they are not going to alter now. Now it is A of 4 less than min. 8 less than 5. So it is false. That means now minimum value is 5 and it is present at position 2. It has to be written in the place 2, then 5, 7, 9, 8. First and second number you leave it now. Now in the min you are going to store 7, right? And its position is 0, 1, 2. So now here A of 3, A of 3 should be compared with min. So A of 3 means how much? 9 less than 7. Condition is false. So then A of 4 less than min. A of 4 means 8 less than 7. It is false. So there is no need of doing any swapping because it is at the right position. Now we'll change our position. Min equal to A of 3, that is 9. Position is equal to 3. So A of 4 less than min. That is 8 is less than 9. It is true. So minimum will get 8 and position will get 4. Position, now it is at 4. No, now it is at 4. Now that has to be interchanged with this 9 position, right? That means 2, 5, 7, 8, 9 it is going to be. Like this, we need to do the program. Okay, let us check. Once after writing one like method, later on you can do optimization, right? Without taking minimum value, right? Can we make any comparisons, right? Like that also we can try. First, we'll write it in one method, main. So we need array int of 50 n comma I. So let it be these number of variables. Printf, enter the value for n, and then scanf %d and n. We'll say printf, enter the elements array for I equal to 0, I less than I plus plus. Scanf percentage d and d of I, and then so here we need one variable min, comma position. So here we'll have a for loop. I equal to 0, I is less than n minus 1. I'll provide I plus plus. Then here let it be same. Later on we'll change. For j is equal to I plus 1 and j less than n j plus plus. And here we can say if a of I is less than a of j. Here first we will store min equal to a of 0, and here let j starts from, and the position is what? 0, right? And this should start always from the next value of position. But here you can't write 0, you have to write I, because I where it is pointing, that value should be there in the minimum. So j should start from the next value of the position. So that comparison, if position is pointing to 0, you have to start comparison with next element. So here I'll say if e of j is less than min, in such case, what you have to do? Min equal to e of j, position is equal to j. Position is equal to j. So this is right. Once you come out from the j loop, position j what we have, right? That should be the value present at position should be exchanged with the value present in I. So here what I do, I need one more variable temp for swapping. Without taking third variable also you can do swapping. So here what I do, temp equal to a of I equal to min, a of min, a of position is equal to 10. Right. Even without taking temporary variable also we can do it. Right. That also we'll see. Now, after that, we'll print it to check whether it is sorted properly or not. So here instead of enter the elements of array, after selection sorting /n. So here printf percentage 3d a of I. This is our logic. Let us check the logic. Go to online compilers. To select any online compiler. Let us execute this. This expected declaration specifier before starting a constant. Semicolon is missing. Where? Here we are missing. Any other variable required? No. J is required. Other all included. Values. So we'll say 5. So okay, here we'll enter some number 8, 9, 5, 3, 7. 3, 5, 7, 8, 9. Right? This sorted. Yes. So this is only the change is what here? J we have to include. Remaining all same. This is one thing. Let us check. Can we do without variable min? Second version will try. So here, so in this case, here I'm storing minimum. This I'm cancelling it. Then how to make comparison? A of position. A of position. Min is not required at all. Right. Now here, but how to interchange? Here it will not be min. It will be A of position. That's all. Even this technique will also work. Let us practically check. Here what we have to remove. Right, let us check. Run this. 5 elements, 6, 8, 4, 9, 3. 3, 4, 6, 8, 9. Right? So one variable saved. So here what you have to remove? Minimum. Okay. This is second one variable we have saved it. Another variable. Even we can do that interchanging of two variables can be done without using third variable. So swapping without third variable. So you can see here. Here you see this one. This equation you can use. If you are without using third variable, if you want to interchange the values of two variable, you have to adopt this. So here where in this place, first I'll copy paste that, then I'll make alteration. So here, so now A equal to A plus B. What is our first element? A of I equal to A of I plus A of position. A of position equal to A of I minus A of position. A of I, here it is A of I, then it is A of position. So now we can answer temp variable. Right. Now let us check this part. And this temp is not required. Let us execute 5, 6, 4, 9, 8, 3. 3, 0600. Means here it is not working properly. Right. This we have to cross check once. Okay, let us be the previous technique only up to temp. Okay. This will check later on and will update. Okay, but it is actually possible without using the third variable. So now what I do, I'll come to the third version, this second up to second version. Okay. Third version will cross check once again. Then we'll update. So the first version and the second version, okay. Yes. This is the first version. In the second version, we cancelled minimum. Okay, good. So here, this is the second version. So now let us trace this. See, now let us trace this. Trace this program to understand whether it's working as per the logic or not. Yes, see here now. Here again we need values. Those same values here it is pasted. I'm going with the second method where min variable is not used. Min variable is not used. So now here, font size a little, I'll decrease. This is the heart of the program. From here you see, first we have n, okay? Then after that I less than n, then position j less than n only, then a of j less than a of position. Okay. So these are the values. Now enter the size of the array 5, I equal to 0, I less than n. It is 0 less than 5 is true. 0 less than 5, it is true. Position is equal to I, means what I should write? 0. J equal to position plus 1. 1, because I is 0. 1 is less than 5, it is true. A of j means how much? A of 1. Less than A of position means how much? A of 0. Comparison between A of 1 and the A of 0. Right, because first number is considered as first smallest number. Second number is being compared with the first number. If the second number is smaller than the first number, then second number will be considered as present minimum number. So now what are the values in A of 1? 7 less than 9. It is true. When it is true, when this condition is true, j is assigned to position. In the j, what we have, that should be written in the position variable. Now after writing this, now where it will go? To which part of the program it will go now? J plus plus, correct. We are in the j loop until j completes, it will not go out of the loop. So j is 2, and after that it will check the condition 2 less than 5 is true. And then here it is A of 2 is less than A of position, that is A of 1. A of 2 means how much? 5. Less than A of 1 means 7, right? It is true. 5 is less than 7. J, assign it to position variable. So in J we have 2, in position also we got 2. Then J plus plus. After assigning the value of J to position, then J plus plus. So here J will be increased to 3. After J plus plus, it will make the comparison. 3 less than 5 is true. Once the comparison is true, it will come to this part where in this it is A of J means A of 3 less than A of 2. So what are the values? A of 3 means 2 less than A of 3. A of 3, sorry. A of 3 is less than A of 2. That is what? 5. Condition is true. So in J, what is there? When this condition is true, assign J to position. So in the J, what do you have to write? 3. So after that, J plus plus, it will become 4. 4 less than 5 is true. And then A of 4 is less than A of 3. So A of 3, what are the values? 8 less than 2. It is false. Now directly no change in the position variable, only J plus plus, condition is false. Right. When the condition is false, it will go to this temp part. Right. So where in this, in A of I, in A of position, whatever we have, they will be interchanged. A of I means how much? A of 0. A of position means last value was A of 3. 0 and 3 have to be interchanged. After interchanging, what are the new values? So here you can see that little forward I'll write so that it should not get clashed with the J value while tracing. 0 and 3. Here 3 means 2 it is. And here I have to write 9 interchanged. Now after this, I plus plus, I is increased by 1. 1 is less than 5 is true. When it is true, it will get inside the body of the loop. And position is equal to I. Position is how much? 1. Now J is position plus 1. So it is true. J less than and 2 less than 5. Condition is true. 2, 3, 4. 3 rounds it will work now. Now it is A of J. That is A of 2 less than A of 1 because position means 1. What are the values? A of 2 means 5. Sorry, here. A of 2 means 5 and less than A of 1 is 7. This new list you consider. New list. This you have to consider. It should not consider the above one. So 5 is less than 7. It is true. So assign a J to the position. In J2 is there in position. Now we got 2. After that J plus plus. So it is 3. So after J plus plus, condition will be checked. So it is 3 less than 5. It is true. A of 3 is less than A of 2. So in A of 3, what we have? 9 is less than A of 2 means 5. 9 is less than 5 is false. So no changes in the position variable, just J plus plus. J plus 4 less than 5 is true. So it is A of 4 less than A of 2. A of 2 position is still at 2. So A of 4 means 8 less than A of 2. A of 2 means how much? 5. Condition is false. Now J loop, it will complete now. 5. 5 less than 5 is false. When the J condition is false, it will come out from the J loop. It will go to the temp part where it will interchange the values. So this part I'll copy and paste. Which are all the two values which will get changed? A of I and A of position. A of position is 2, A of I is 1. So now in this A of 1, right? A of 1 should be exchanged with A of 2. And that means here 5 and here it is 7. Right. Now after this, where it will go? I plus plus. Right. So it will go to I plus plus 2. 2 less than 5 is false. False or true? True. And position is equal to I. Where is the position variable? This is only position variable 2. And j. J equal to position plus 1, 3. J less than n. We are here now. J less than n means 3 less than 5. Only 3 and 4. Only 2 round comparisons. It is true. And after that, A of 3 is less than A of 2. A of 3 means in the new list how much? 9. 9 less than 7. Condition is false. No change in the position variable J plus plus. 4 less than 5 is true. A of 4 is less than A of 2. Still it is at 2 only because change the swapping did not happen. So now it is A of 4 means how much? 8 less than 7. So it is false. So means no change, right? So now directly J plus plus 5. 5 less than 5 is false. So no swapping temp apart. Now here temp apart will work, but interchanging of I and position. I and what is the value of I? 2. Position is at 2. Interchanging between 2 and 2 only. So no changes, right? But what is happening is unnecessarily one round these three statements are working. Because of that, time will be wasted. In the next version of the same program, we should make some arrangement in such a way that if there was any change in the position variable, then only these three lines should work. Otherwise, it should not work. Right. So that if we do one more level of optimization, it will be right. So some more time will be saved. That we can do it here only. If a position is not equal to I, then only change it. If position is equal to I, don't work it, right? Like this also we can do. So now I plus plus, it is 3. 3 less than 5 is true. And J position will be 3, right? And J will be how much? 4. 4, only one round comparison. 4 less than 5 is true. Now it is A of 3. 3 or 4? A of 4 with A of 3. What are the values? 8 less than 9. It is true. So in the position you should get what you should get? 4. J plus plus 5 less than 5 is false. Now temp part will work. A of I and A of position should interchange. What is A of I? A of 3. A of position is A of 4. So 3 and 4 have to be interchanged. Right. 3 and 4 have to be interchanged. So this is the new. So now it is 3 and 4. Here 8, here 9. But still program not completed. Now again I plus plus 4. 4 less than 5. Condition is true. J will be how much? 4 plus 1, 5. Sorry, this is position. It is 5. And the condition 5 less than 5 is false. 0 comparisons. Now still program not completed. I will be 5. 5 less than 5 is false. Now it's completed. Like this, it works, right? So yes, this is all about what is that? Comparison. If you want, you can write here the swapping should be done only when position is not equal to I. Then only it should work, so that unnecessary swapping when there is no change in the position variable should not be done. This also you can include. Okay. So this is all about selection sorting. That means once after writing in the program in one way, check what all things we can remove it, we can optimize it. That continuously you should do. And we can't say that this is only the final solution of the selection sort. So still you can try, because all of you know mathematics very well, right? Who knows mathematics very well, programming will be very, means they can handle the programming still in a very best way. That is why try some more optimization in this program. Okay. Thank you.